So why do we start with systems thinking? Mostly because the city itself um, is a dynamic. It's alive. It's a dynamic like organism. It would I would really say that the city is alive and it's not kanang static. It's constantly changing, improving, and then if you sort of develop one side, you're basically taking resources away from other parts of the city to create that new development. Like you're taking labor, building materials. So something has to be taken in order to create something new. So this is how systems thinking will like help us. Like it helps us think where are the materials coming from? Are these materials good for an environment? Are they sustainable materials? The cost for like transporting those materials. So we're not just thinking about the single site, but how that single site affects everything around it. So this also touches on like what do you call this? Thinking about site analysis. I think that's the most familiar term for us, like architecture and landscape architects. We always do site analysis. We look at the big picture, but how big that picture is really depends on like your personal preference or your training. Here in this class, we'll try to sort of make it more specific. How far out should we look at, like to determine the impact of our developments? And then, of course, I want to switch this up. I'll just switch this up now. I can't seem to enable anything. I'll do that later. I'll make a new slide. But anyway, we'll talk about sustainability first and parts of the city today. And then next week, we'll be talking about urban infrastructure with a short quiz in the middle of that. And then I don't know why I keep changing the just after sustainability and urban infrastructure, we'll talk about disaster risk management. And then I think we'll save governance and financing for last, and depending on how we go, because I keep floundering over this, because like governance and financing is very important, but I think we can save that for later. We'll just use the more general topics and then talk about how we get funding for like our different projects and like who do we talk to in government to get those projects done. Okay, next, thinking in systems. You have a copy in the Google Classroom. Let me just double check if it's there. Google Classroom over here, stream. So you have the book here. Oh, wait, where's the book? It's over here. So we'll only like, basically you can read the whole book if you want. It's about 200 pages, not that long. Mostly we'll be focusing on the first few chapters, like chapter 1 and 2. How does systems influence behavior, and then how does the system influence us? Like the different systems in our lives, and we'll like I'll just give you a brief summary, so you'll be like inspired to read the book. Okay, so this mainly systems thinking sort of connects to systems theory. So let me just quickly read here so you can like listen to this later on. Systems theory is the interdisciplinary study of systems. A system is a cohesive group or of interrelated and interdependent parts, which can be natural or human-made. So for our case, since we're talking about the city, the system we're talking about is man-made. Like who decides what development gets approved? How do we manage land? Which part of the city should be what's this for commercial, residential, etc. Then how do we sort of like approach or like manage these problems? So over here is just a diagram of the different kinds of systems. We have, for example, what's this? What's the most closest here? I think collective behavior is very important for urban planning and urban design. Like you're looking at how people behave in a specific area, social dynamics, collective intelligence, self-organized criticality. So this is a very like these are the very kind of super deep, super science stuff. But we'll focus on the more kind of basics lang, the simple stuff, because each of these different topics could be worthy of kind of a whole sem on their own, or like a different sort of training. Okay, so these are the different chapters over here. Not so long. It's like part 1, part 2, part 3. I think part 1 is really, if you're not gonna read until like page 111, the part 1 at least is only like 35 pages long. So it's very kanang abstract, I would say, but at the same time, I think it gets the point across. So, according to Meadows, the author of Thinking in Systems, a system is an interconnected set of elements organized in a way that achieves something. So, there's a goal, there's the system creates a goal. So, the system doesn't exist without a goal. So, what is the goal of a city? Um, I think if you think about it from a economic standpoint, to generate money, provide opportunity, create jobs. From a physical standpoint, like the structures itself, the environment, a city's goal is to provide housing, to provide spaces for people to work and live, and everything in between. And then on the social side, like the social and cultural side, a city provides what they call this a space to gather, to create meaning. And these are the more abstracts for me, the more interesting parts of city. Not the buildings, not the built environment, but the people. It's really who designers are designing for. Those are our clients. In architecture and landscape architecture, you have a specific client, like a group of people, a developer. But in urban planning and urban design, you're designing for the public at large. And then at the same time, you're because you're designing public space, that also impacts private space. So you're designing for the whole city, basically. So that is the goal of urban planning and urban design. So the example Meadows talks about, like a very simple example, is how uh, the rainwater cycle works. So that if you think about it as a system, so the elements inside the rainwater cycle, you have the rain going into reservoirs, and then the water reservoirs evaporates back up into the sky, and that creates a cloud. And then I'm not super super expert on this like basic rainwater cycle stuff, but once the water gets accumulated, and then it falls down again as rain. So that it's a cycle, a cyclical system. Also, you could also count river inflows going into the water reservoirs. This could be like physical like man-made reservoirs or natural reservoirs, and it gets discharged into the different water systems like naturally, and then of course like evaporates again, and it goes up into the sky, and it becomes rain again. So notice the labeling of inflow and outflow. So you have like materials input and then materials output, and then connecting that with cities and like urban design and urban planning. So what is the inflow for urban design and urban planning? That's basically all the materials and all the what do you call this, elements that create your proposal, your design. So for landscape architecture, it's the natural land. Where are you getting the, excuse me, the plants and the different elements of your design? For architecture, it's a different what do you call this, professionals you need to gather together, what materials you'll be using. So those are your inflow, and then your output of course is your design. And then over here on the bottom, you have a graph showing like the reservoir water level over time. And time is another dimension that is like usually not talked about so much in it's in construction. Usually we propose the design, yes, will be finished in kanang 1 year, 2 years, and usually malimta na, and then behind na mo sa schedule. Bigger projects are more strict with their schedule, but this also shows that in very complex systems like a city, your inflows and outflows change over time. Like for example, this is very, just tell me if I'm kanang reaching or it's too abstract. There are times when you have a lot of inflow or rainfall, and there are times where you have not so much rainflow. This is like an example in let's say a climate setting. The whole point is that it's everything inside the city and in nature and whatever is constantly changing. Like for last year, before the pandemic hit, we had so many projects, and because the pandemic hit, we had to stop those projects because we were worried about infection. So right now, I think the construction industry is really facing a big challenge, how to sort of develop more projects at the same time, manage infection rates and like worker safety. So just thinking about that, that we live in a system that that whenever we take or create a project, we're taking resources away from the city, and that's why it's very important that we learn how to manage um, what they call this, our projects, making sure that we don't take too much because we have, as you all know, very limited resources, and it's even more challenging now because of the pandemic. So these are just some terms that Meadows uses to like simplify systems. So you have inflow, outflow, and then stock. So stock is an observable or quantifiable aspect of a system. So the stock can be anything. For for design, our stock could be our building materials. Stock could be our workers, our designers, and then what do you call this? For a project or proposal, I think it's a lot better once we have like an example. Um, your stock will be the design, the materials for design. So your inflow is your proposal or your idea. The stock is you're creating the elements of your design, and the output is your design itself. And then feedback loops, which we'll be talking about in the next slide, is formed when a change in stock affects the inflow or outflow of that stock, i.e., triggers a process to increase or maintains or decrease that stock level. So this is a little bit more difficult to think about when you're talking about like a one-time project, like a building or a landscape architecture project, like a development of a site, because you only do it once. But in bigger projects like citywide projects, it's always you have to think about feedback loops, because once a project is done, you need to have like a maintenance plan in place, a sustainability plan in place, like who will take care of that project. And then let me just switch here to a project so I don't lose you guys. Let me open up a video over here. So let me show you guys what me and some of my former students are working on. Okay, this one. So can the video be seen? Is the video playing?
Yes, sir.
Okay, so this was done just like a couple days ago. So the idea of this project is a pedestrianization or a temporary pedestrianization of Basilica del Santo Niño in Cebu City. So this is where I'm currently staying. Not in this area, I live in Talamban, but this is the area in 3D. So you guys who are not from Cebu City can understand the context. So before I go to the video, I need to introduce you to the site and the project. So this is the site. Cebu City Hall is over here where my mouse is. You have Magellan's Cross, Basilica del Santo Niño, the Metropolitan Cathedral, and of course, Plaza Independencia. So this is one of the, also I forgot to mention the, where is it? This one. This one is I forgot, the Sugbu Chinese Heritage Museum. So this area is one of the oldest parts of Cebu City, and I just listed off some very important heritage sites. So the city is planning like how do we maintain or make these areas like more accessible, easier to travel, and like the goal is to attract more tourists. At the same time, the funds that attract these tourists will be used to maintain and keep these sites kanang clean and well maintained, for lack of better words. So already there are several systems working in place here. So let's take the tourism angle. The inflow is you want tourists to come to Cebu. The stock is why do you want tourists to come to Cebu? You want their money. And the outflow is you want their money to preserve, like to create economic sustainability in Cebu and to preserve these heritage sites. And the feedback loop is, I wish I had like a screen. Okay, let me just open up Photoshop real quick. Or maybe I can just use Paint. Paint is like faster. Wait. I have a tablet here. Let me just set it up. Where did I put it? Oh, hang on. I thought I could survive just with the PowerPoints. But I need to really draw. Okay, so there are several systems going on in this area of Cebu City. So let's take the tourism example, which is like a very easy example, I think. Can I zoom in on this? I can't seem to zoom in. Anyway, can I make this bigger? Okay, there. So we have our inflow, which is the tourists. I'm just gonna make inflow here. We have tourists, and our stock is the tourist money, and then we have like another thing here. This will be the feedback loop. So we have the kanang maintenance or like the improvement of our kanang heritage sites maintenance, and that will like attract. Let's just say what do they call this? I think the tourists would be better if it's here. Wait, where's my eraser? Eraser. Okay, that's bad. Tourists, and let's say this is the inflow, and the stock is the heritage site. Okay, that's a lot better. Heritage sites. So this is the kanang, let's say the tourism system. So I think this applies to anywhere you have like a tourist attraction. So the inflow is cash, the stock is your heritage sites, and then your stock two, you have another stock, is your tourists. So if you increase the number of tourists, you'll get more money, and then you'll improve your kanang heritage sites, and which will in turn attract more tourists. So this is a positive feedback loop. Alternatively, if you have less tourists, you won't have the money to improve your heritage sites, and that will make your tourists less. So it's a direct relationship. More tourists equals like more money and better heritage sites. Less tourists means less money, worse tourist heritage sites. The other system would be a kanang negative system. Basically, the more of something, it becomes worse. So let's say balik ta sa Cebu City over here. Let's say one of the challenges in this area is kanang pollution, because you have like some squatter areas here. Some people don't clean up. So this would be an example of a negative system or a kanang a vicious feedback loop. So let's say the stock is still our heritage sites. Heritage sites. Let's just call this our primary stock, or the stock that we want to focus on. And then our secondary stock will be pollution, or like the trash stock to, let's just say, secondary. Excuse my handwriting. So if you increase the pollution in this like site, you'll like decrease the kind of quality of heritage sites, which then further what do you call this, entices or makes people care less about the heritage sites, which will also like create more pollution. And it moves the same way, but the effects here are more negative. So basically, this is how you think about systems. And then there are several more systems like going on in this site. And then I would like you guys to sort of think of some. So we have I talked about tourism and pollution. What other kinds of systems do you think, you can just guess, that will be present in this kind of situation in this part of the city? And then I will stop recording here because I know it will take a bit long, but this will be the first part of the connected to the other lesson. So if we're going to talk about systems and we get to like sustainability, we'll be using ideas and systems thinking to sort of describe and have some plans and like some direction for sustainability. Okay, so we talk about stocks and feedback loops. The stock can be anything. Usually for us, because we work in the construction industry, the building, the sites, the physical aspects that we can sort of design and modify. And the inflow and outflow are usually things that are moving within that area, like the people, the cars, and maybe even like behavior. And then buying, selling, polluting, those kinds of things. And then over here, we have the different kinds of loops, which I attempted to explain. There's a balancing loop. What Meadows calls a balancing loop is a goal-seeking sort of loop. For example, her example here is a thermostat that regulates pressure. It brings stability, but also resists change. So the example of a thermostat, or let's say in our case in the Philippines, an air conditioner, if you set it to 25 degrees, the air conditioner will try to keep the room at 25 degrees and then not change at all the temperature. If we bring that to our example of pedestrianization, we want to increase like a stock, like the number of people walking in that area. But how do we sort of is the goal? Do we have a goal of like how many people per day do we want to go there, and do we want to maintain it? This is another question that I don't have the answer to. Another kind of loop is the reinforcing loop. So this is also called the virtuous or the vicious cycle. Basically, what I explained earlier, when we have a loop that sort of increases the stock or like continually increases the stock. Our example was the heritage sites and the public space. If it becomes a reinforcing loop, it continuously improves because like the space is getting better because more people are going there. And then alternatively, there's also a vicious or negative side. Like if the people going there don't take care of it, like for example, public space, it will become a worse and worse public space. So the main difference is balancing loop keeps everything the same. Reinforcing loop makes everything like better and better or worse and worse. So this one is changing. This one resists change, and the reinforcing loop is always changing. So another example here is like a virus, very timely. This was written in, I think, early 2000s. If the more people have the virus, it spreads faster. So that's what we're experiencing now. So the example here is zoo. I think I'll just skip that because we already had like the example of pedestrianization. And then systems thinking, summary principles. There's also a summary inside the book. So if you look at the appendix of the book, I was supposed to put a picture here, but I never got to it. But there's a summary inside that PDF, which you can use. Okay, some my personal critique of the book itself. So there's a positive outlook to it. It like motivates people, especially for us in the design and the construction field. Um, Challenges us to change their perspective, our perspective, changer. I don't know why I mistyped that. The problem is sometimes it gets a little bit lost in itself, like it's meandering, and there are very little examples which relate to urban planning. But yeah, hopefully I made that clear with our example of the pedestrianization project.